Have you ever noticed how different ingredients in a recipe, like a pinch of salt versus a cup of flour, play vastly different roles due to their quantity? Similarly, in machine learning, your data often comes with features or ingredients that have widely varying scales. Min-max scaling is a data preprocessing technique in machine learning that transforms numerical features to a fixed range, most commonly between 0 and 1. This process ensures that all features contribute proportionally to the model's learning, preventing features with naturally larger values from dominating the learning process. The core reason we employ min-max scaling is to level the playing field for our machine learning algorithms. Many algorithms, such as k-nearest neighbors, support vector machines, and neural networks, relying on distance calculations or gradient descent optimization. If one feature has a range from 1 to 1000 and another from 0 to 1, the larger ranged feature will disproportionately influence these calculations, pulling the algorithm's focus away from the potentially equally important smaller ranged feature. By scaling, we ensure that the magnitude of a feature does not unfairly bias the model's performance. To apply min-max scaling, you calculate a transformed value for each data point using a simple formula. You take the original feature value, subtract the minimum value of that feature from the entire dataset, and then divide the result by the range of that feature, which is its maximum value minus its minimum value. This arithmetic operation maps the smallest original value to 0 and the largest to 1, with all other values falling proportionally in between. An interesting aspect of min-max scaling is that it preserves the original distribution shape of the data for each feature. This means that if your data was skewed before scaling, it remains skewed after scaling, but within the new 0 to 1 boundary. However, it is also highly sensitive to outliers. A single extreme outlier can significantly compress the range of the majority of your data points, making them appear very close to each other after scaling. Understanding and correctly applying min-max scaling is a fundamental step in preparing your data for many machine learning models. By normalizing your feature scales, you can significantly improve model convergence, enhance prediction accuracy, and ensure that your algorithms learn from the intrinsic patterns in your data rather than being swayed by arbitrary differences in scale. It is particularly valuable when you need a bounded output for your features and when your dataset is not significantly plagued by extreme outliers.